Hey everyone, let's just do some practice problems on if-else statements and logical operators in Java. Um, if you need a quick refresher, you can always check out my video on that, on those topics. But we're just going to go over 30 problems or so within this Logic 1 section in CodingBat. So let's just get started with the first problem called cigarParty. So we're dealing with squirrels getting together for a party that like to have cigars. It's a successful party when the number of cigars is between 40 and 60 inclusive. And that's if it's not the weekend, because it then says, unless it is the weekend, there's no upper bound on the number of cigars. And we want to return true if it's a successful party or false otherwise. So seems simple enough. We have this method declaration called cigarParty that returns a Boolean value, has two parameters, cigars, which holds an integer, and is weekend, which signifies if it's a weekend or not. That is a Boolean value. And so we just want to check for these two conditions, these two success criterias. So the first criteria, so that is when it is not the weekend. I can write it like this. And if it's not the weekend, we want to check if cigars is between 40 and 60 inclusive. So we need to include that greater than, or this equal to, as part of those conditionals. So if these two conditions pass, the party is successful. Else, if it is a weekend, which is signified by this else statement, since we already checked for if is weekend is false, we just want to check if cigars is greater than or equal to 40 now, since there's no upper bound. So if that's the case, these two conditions pass now, we can just return true. Otherwise, if none of these conditions pass, then the party was not successful. So we check our answer. Everything is good to go. Next question is called dateFashion. So you're on a date trying to get a table at a restaurant. You and your date's stylishness are going to be rated from 0 to 10. The result of getting the table is an integer value with those three values. If either of you is very stylish, which is an 8 or more, then the result is you getting the table, with the exception that if either of you has a style of 2 or less, then you don't get the table. Well, because I guess they don't allow people to dine in their establishment if you have a poor fashion sense. I guess, I don't know. Otherwise, the result is maybe you do get the table. So this question, yeah, you need to especially be careful with reading problem statements like this, because with this sentence here, with the exception that if either of you has a style of 2 or less, that implies that this condition needs to be checked first before you check for this condition. So let's do that. So we'll first check for the style of 2 or less. So you having a style of 2 or less, or your date having a style of 2 or less. Then we want to return 0 to have a result of having no table. Then we want to check if you do get the table or not. So you or your date having a style of 8 or more. And then else, if none of that applies, then we return maybe you do get the table. Next question is called squirrelPlay. We got squirrels in Palo Alto spending most of the day playing. They play if the temperature is only between 60 and 90 inclusive. Unless it's a summer, then the upper limit is 100 instead of 90. And so we're given a temperature of an integer value and an is summer Boolean value as parameters for our method. And we want to return true if the squirrels do play and false otherwise. So seems simple enough. We have a Boolean value that we need to check for. So let's check for that first, which is summer. So let's just check if it is the summertime, since order doesn't really matter here. So we could say this. Then the range for the temperature should be between 60 and 100. And that is one of the cases where the squirrels do play. And then for if it's not the summertime, then the temperature range is between 60 and 90. Otherwise, the squirrels do not play. Next question is called caught speeding. So you're driving a little too fast and a police officer stops you. We want to write code to compute the result, which is either no ticket, a small ticket, or a big ticket, at 0, 1, or 2 respectively. If the speed at which you were going at was 60 or less, you get no ticket. If the speed was is between 61 and 80 inclusive, you get a small ticket. So maybe a small fine or something. But if you speed at 81 or more, then you get a big ticket. So I'm thinking misdemeanor, or maybe reckless driving. I don't know. Probably just a big fine amount on top of that, but whatever. Unless it's your birthday, your speed can be 5 higher in all cases. So we have the speed and his birthday parameter values here. So let's just check for the original conditions here, which was this sentence, or these sentences, and that is when it is not your birthday. So let's check for not his birthday first. So if it's not your birthday, then we go through these original ranges of speed. So if the speed was 60 or less, you get no ticket, which is a 0. If you were going between 61 and 80, that's a small ticket. Otherwise, we get a big ticket here. Now we should check for the other condition, which is when it is your birthday. So we can just probably copy this whole branch and then just increase everything by 5, or the ranges by 5, like that. We got sortaSum next, and we got 2 ints, A and B, and we want to return their sum. But if the sum is in a range between 10 and 19 inclusive, we just need to return 20. So let's check for if the sum is between 10 and 19 first. So if the sum is greater than or equal to 10 and less than or equal to 19, since this indicates a range, then we just want to return 20. Otherwise, we just return the sum straight up. Next question is called alarmClock. Given a day of the week encoded as a number or an integer value, 0 being Sunday, 1 being Monday, and so on, and a Boolean indicating if we're on vacation or not, return a string of the form 7 o'clock, indicating when the alarm clock should ring. Or I guess this just indicates the time, like the actual time format. On weekdays, the alarm should be 7 o'clock, and on the weekend, it should be 10 o'clock. Unless we're on vacation, Then on weekdays, it should be 10 o'clock, and weekends, it should be off. Wow, that's a lot of checks. So in the end, we want to return an integer, or a string, sorry, in the form of telling time or off. We're given a day, which is these integer values being encoded, and then a Boolean if we're on vacation or not. So I don't think order matters here, reading this the first time through. So let's just go through this one by one. Return a string in the form 7 o'clock, indicating when the alarm clock should ring. So on weekdays, the alarm should be 7, and on the weekend it should be 10, unless we're on vacation. So this sentence implies that we are not on vacation. So let's check for that first. So not on vacation. Then we need to check for weekdays, which, given this, weekdays are Mondays through Fridays, which is 1 through 5. So we can check if they greater to 1, days less than or equal to 5, and we should be returning 7 o'clock here. It's a string. Else, or on the weekend, we want to return 10 o'clock. To sleep in a little bit, I guess. And then we want to check if we are on vacation. Then on weekdays it should be 10, and weekends should be off. So we can just copy this. This should be 10. This should be off. And I think that should be fine.
Next question is called Love 6. Number 6 is a truly great number. Given two integer values a and b, return true if either one is 6 or if their sum or difference is 6. And then they say that we could use the absolute helper function from the math class to compute the absolute value of a number. I think that has to do with this statement here, or helping us compute the difference, because a and b can take on negative numbers, I would assume. So we can first check if either one is 6. So that seems simple enough. Like this. And if that's the case, we can return true. We also have the other case where the sum or difference is 6. We can check first the sum. So if the sum is equal to 6, we also return true. And then we can say if the difference is 6. And let's see. I'm thinking about a whole bunch of combinations where we can compute the difference since it doesn't really specify. So if I'm wrong, we can definitely go back and fix. But and I would assume that this is already imported for us, or maybe not. I don't know. They gave us this, so I'm hoping it works. Let's see. We can do this to compute the difference. Does that work? I don't know. Well, we can comment that, this is to find the difference. And then if all else fails, we return false. Int cannot be converted to Boolean. Yes, because I forgot that. Oh, looks like that was right. Next question is called in 1 to 10. So we're given a number n. We want to return true if this number is in the range 1 to 10 inclusive, unless outside mode is true, in which case we need to return true if the number is less or equal to 1 or greater or equal to 10. So it seems like there's two conditions here. So we'll tackle this one first. This is when outside mode is false. So we can do this, and then since we're only checking for one condition here, we can just write some shorthand code. We can say return, and then this will return true if n is in the range 1 to 10. So we can say, and that's inclusive. So we can do something like this. And similarly, if outside mode is true, we can do this, and then basically the same thing, and then less or equal to 1 or greater or equal to 10. Next one we have is called specialEleven. This question will say a number is special if it's a multiple of 11 or if it's one more than a multiple of 11. And we return true if the given non-negative number is special. So as a precondition, n will always be non-negative. Then it says we can use a mod operator to help us. And if you recall, the mod operator gives us the remainder of an operation. So for example, 7 mod 2 is 1, since 7 divided by 2 is 3, but gives a remainder of 1. So mod retrieves that remainder part. And we can use that to our advantage here, since this is asking for multiples of 11. Any number that's a multiple of 11 will give a remainder of 0, so we can check for that. So this is just a simple if n mod 11 equals 0, or n mod 11 equals 1 to account for this second part of the or, if it's one more than a multiple of 11. And if that's the case, we return true, otherwise we return false. Next question is similar to the last question. This is called more 20. You want to return true if the given non-negative number is 1 or 2 more than a multiple of 20. So it's pretty similar to what we had last time. This time we just need to check n mod 20 equals 1 or n mod 20 equals 2. And we return true. That's the case. Otherwise we return false. This next question also uses the mod operator. It's called old35. Return true if the given non-negative number is a multiple of 3 or 5, but not both. And so, seems simple enough. We just need to include some more logic to account for the but not both condition for this problem. So we can just check for two things. We can first check if the number is a multiple of 3 and not a multiple of 5. Second condition is basically the vice versa of that, I guess. Multiple of 5 but not a multiple of 3. You can return true if that's the case. Otherwise, it is false. Next question is called less 20. Looks like this is another mod question, or another question that uses the mod operator. So we want to return true if the given non-negative number is 1 or 2 less than a multiple of 20. And it gives us some extra test cases here. 38 and 39 return true, but 40 returns false. And so this is different than the previous 3, I think, where it asks for, say, multiples of 20 or multiples, or 1 or 2 more than a multiple of 20. So in this case, doesn't make sense for us to do n mod 20 is equal to -1 or -2, since I don't think that's even possible with non-negative numbers. So we just gotta go backwards and say, well, what's 38 mod 20? Looks like that's 18. 39 mod 20 is 19. So we can just replicate that in our if condition. So we can check n mod 20 equals 18 or n mod 20 equals 19. And if that's the case, we return true. Otherwise, return false. Next question is called nearTen. Seems like this is another mod operator question. I'm not sure how much more there's going to be, but we're given a non-negative number again. We want to return true if the number is within 2 of a multiple of 10. And then it also gives us a reminder of what the mod operator does. So this is interesting because it says within 2. So that means less than 2 or more than 2 than a multiple of 10. So there's 2 conditions we need to check for. So pretty much the same thing that we've been doing the past few questions now. Multiple of 10 equals 2. No, I guess we can just branch it out to 2 conditions. So we return true if it's, what would this condition be? More than 2? If the number is more than 2 of a multiple of 10. And then we can also check if it is less than 2 of a multiple of 10. So 10 minus 2 is 8. Kind of like if the number was 18, right? 18 mod 10 is 8, which is within 2 of a multiple of 10. That's not good. Let's see what I did wrong. We could also check with our test cases here. So 12 mod 10 is 2. 17 mod 10 is 7, which is not within 2. Oh, okay, so maybe it has to be like within a range, right? So 19 mod 10 is 1, which is within 2, I guess. So I guess we can scratch this. Something like that. Since 0 is pretty much guaranteed with a non-negative number if you take the mod of something. No? Got 2 more. So 19 mod 10, is 9, okay. So I guess I gotta check for the other way around, which is greater or equal to 8, right? Since 19 mod 10 is 9, which is 19 is within 2 of a multiple of 10. Yeah, there we go. Okay, we're stepping away from mod questions now. This question is called teenSum. We're given 2 integer values, return their sum. However, teen values 13 through 19 inclusive are extra lucky, so if either value is a teen, just return 19. So this means we should check for this condition first before returning their sum if that's not the case, if this condition was false. So we can check first if A is greater than or equal to 13 and A is less than or equal to 19, or if it's the same for B, or the second integer, and we want to just return 19, otherwise we just return their sum. Next question is called answerCell. So your cell phone rings, return true if you should answer it. And so these are all going to be cases or conditions that we need to check for. So normally you answer, except in the morning, you only answer if it's your mom calling. But in all cases, if you're asleep, you don't answer. And so we're given 3 Boolean arguments for this method. So I think this is a question where order matters when we're checking for these if-else conditions. So I think we should check for this one first since it says in all cases. If you're asleep, then I guess, of course, you don't answer the phone, so we should check for if you are asleep, you don't answer, which is false. And then for the other condition, you answer except in the morning you only answer if it's your mom calling. So I guess to translate that, I guess you could do a nested if statement. So if it is the morning, you only answer if it's your mom calling. So you check if it's your mom calling, then you return true. If it's in the morning as well. Otherwise, we are in Java. You return false. And then if all of those cases don't return anything, we should return that we don't. Oh, we should return true since normally we do answer. Okay. There we go.